Konnichiwa, watashi wa Kayla desu. Ju go sai desu. Hello Australian Pavilion, my name is Kayla. I'm 15 years old and I'm from Hawkesbury High School, New South Wales, Australia.
Watashi wa Janelle desu. Juni sai desu. And my name is Janelle. I'm 12 years old and I'm from Colo Heights Public School. Our team's name is Lunar Seeds and our mission has been learning about food production in space. So Kayla, what are ways we can produce meat and fish in space?
Well, Janelle, from our research, we have discovered two main ways we can produce meat and fish in space. One of these being lab-grown, also known as cultured meat. By taking stem cells from a live animal and placing them into large tanks known as bioreactors, we can replicate the inside of an animal's body and supply cells with the nutrients needed to multiply, separating them into three groups of meat: muscle, fat, and connective tissue, where they are then rearranged, creating the type of meat being produced. For example, steak or mincemeat. In space, scientists can take a small proportion of animal muscle tissue to space where it is then processed and harvested to eat.
Another option for growing fish in space is through aquaponics, the method of growing plants with fish in water. We can feed these fish using pellet food made from insects or microbes grown on board. The fish's waste is then used to grow plants which purify the fish's water.
And now our Japanese teammates will present.
Hello everyone, we are Sakurako, Shu, Natsuki, and Yuriko, the Lunar Seeds from Ritsumeikan Senior High School. We are going to talk about food production in space, focusing on vegetable cultivation. Our team name is closely connected to our theme. We see ourselves as seeds, small and fragile at first, and humble beginnings. But with care, perseverance, and the right environment, we can grow, adapt, and eventually achieve great things. In the same way, we hope our simple research will take root, undergo challenges and changes, and bloom into something that will benefit the future of space exploration.
So what did we explore? The first is about astronauts' current health conditions. Studies show that astronauts could have health issues in space due to lack of fresh food and CO2 buildup in the spacecraft. On the International Space Station, too much CO2 from astronauts cause headaches and dizziness. The CDRA Voldac system and lithium hydroxide canisters as chemical filters are used, but these also have some problems. Also, astronauts rely on tanks, machines, and emergency oxygen candles for oxygen source. Plants could be the solutions. We can have fresh vegetable cultivations to reduce these problems. Our project involved three main elements: vinyl greenhouse, photosynthesis, and exercise.
We chose lettuce for our test crop. It can grow quickly and is also nutritious. In our design, CO2 will come from the astronaut. All astronauts have to do aerobic exercise for 30 minutes daily. The CO2 they emit during exercise can then be circulated into the lettuce greenhouse. The plants gives out oxygen which can be used by astronauts. So this creates a circular system. Astronauts gives out CO2 for plants and plants gives out oxygen. Here are calculations and assumptions we made. An astronaut weight about 60 kilograms can produce about 42 liters of CO2 from 30 minutes exercise. A lettuce needs about 3.375 kilogram of CO2 to grow. When we grow about 22 lettuce from 30 minutes of jogging.
So in theory, this can work. However, a plant's growth can be highly affected by the amount of water, light, and nutrients. And also the level of CO2 needs to be highly monitored. And constructing the greenhouse could also pose concerns of protection from radiation and humidity control. So our ideas can make arsenals healthy by combining exercise, circulation of CO2, and greenhouse system. This could help increase the ratio of CO2 in ISS or to grow food independently in the future. There are still many challenges, but we believe our idea may be a possible step toward grow food towards producing a closed life support system. We thank our friends from Colo Heights Public School and the Connecting Mind project through this whole journey. We hope we can continue our search for better solutions. Thank you.
We would now love to share with you a video our team from Colo Heights Public School has made showing all the work we have done over the past few months on this project. Konnichiwa, watashi wa Charlie desu, Johnny Sai. What are we focusing on?
Our team's name is Lunar Seeds, and we are focusing on the production of food in space, but mainly on the moon.
How did we come up with the name Lunar Seeds?
We believe the name Lunar Seeds really connects with our goal for the Connecting Minds project, which is growing food in space. Lunar, meaning moon, and seeds, being essential for growth, can have many meanings, like the personal growth astronauts undertake on their missions to space, as well as the production of plants as they undergo their own developments on the moon.
Awesome!
If I was going to work for NASA in 2030, I'd be a space engineer, so that I could build rockets for future space expeditions. By the year 2030, I will be 17 years old. Thank you.
I learned that scientists built a 3D clintostat so they can study the responses and trick the plants into thinking they have gravity when there is none, so it can grow straight in space. I also learned that strawberries and peppers are the most successful and best fruit to grow in space because of their size, and they are high in nutrition and they grow quickly.
A spray called 3D geothermal protective spray, which can be used to create a little bubble over the top of the plants, which has helped the plants grow simultaneously.